Good morning, my YouTube viewers. In this video, what we're going to do is we're going to do a practice question, and this practice question is going to be on male heights. You are conducting a survey to estimate the average height of adult males in a city. You collect a random sample of 100 heights with a mean of 175 centimeters and a standard deviation of 15 centimeters. Calculate the 99% confidence interval for the population mean height. So we're going to solve this problem in Python. And so in order to solve the problem in Python, we're going to import 3 Python libraries. So the first library we're going to import is NumPy, is NP, which is your numeric library. And then we're going to import scipy.stats as stats, which is the statistical module in the library of SciPy, which is a scientific library. And we're going to import matplotlib.pyplot as PLT, which is the visualization library. So we want to define our data. So the sample mean is 175. The sample standard deviation is 15. The sample size is 100. And the confidence level is 99. So we calculate our 99% confidence interval. Confidence interval equals stats.norm.interval, brackets, confidence level, comma, log equals sample mean, comma, scale equals sample standard deviation divided by the square root of the sample size. And then so after we have calculated our confidence interval, what we're going to do is we're going to generate our sample data. And how we do that is we're going to set our seed. And what happens when you set your seed is you set it up, you define it to a standard number. So every time you run the program, it's going to start out with that predefined number. So your program will work the same every time you run it. And that's why you set your seed. So np.random.seed, and I put 42 in the brackets, but you can put any number you like. So now sample height equals np.random.normal, brackets, log equals sample mean, comma, scale equals sample standard deviation, comma, size equals sample size. And now we print our 99% confidence intervals. And so your 99% confidence intervals are 171.14 to 178.86. That's your confidence interval where the mean is going to fall. So now what we do is we plot the sample heights and the confidence interval. So we're going to create a figure, and the fig size is going to be 6,4. We're going to create a histogram. So it's going to be plt.hist, brackets, sample heights, comma, bins equals 15, comma, color equals blue, comma, edge color equals black, comma, alpha equals 0.7, comma, label equals sample heights. And then we're going to put some vertical lines in the graph. So plt.axv line, brackets, confidence interval 0, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals lower bound confidence interval 0. You have plt.axv line, brackets, confidence interval 1, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals upper bound confidence interval 1. Then you have plt.axv line, brackets, sample mean, comma, color equals green, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals mean. So the X label is going to be height in centimeters. The Y label is going to be frequency. The title is going to be Histogram of Sample Heights with 99% confidence interval. You're going to get a legend, and you're going to get a grid, and we're going to show you the histogram. So this is the histogram of sample heights with 99% confidence interval. So the blue bars, that's your histogram, that's the sample heights. So the lower bound is 171.14 centimeters, and the upper bound is 178.86 centimeters, and the mean is 175. So you're doing your confidence intervals based on the mean. So 99% of 175 is 171.14 to 178.86. So that concludes this video on this sample question, and the next video is going to be another sample question, and I hope you decide to watch it.